Well, this is the latest addition to the Open Energy Monitor shop. It's a three relay Wi-Fi module for switching loads. Can be used for a variety of different uses. You can see it's got three high quality 10 amp relays fitted. Output blocks from each of the relay are live and neutral. A lot of discussion in the forum at the moment is whether these should have been power free, so that it could have been more easily integrated within central heating systems, but that debate's still ongoing. It's got its own regulated power supply on board. As you can see, it's just being fed via fly lead with a plug on straight into this block here, and the board is split into two. As you can see, it's got good separation there, the physical barrier between the high voltage side and the low voltage at the bottom. It runs pretty much on this little chip here, the ESP8266, which is growing in popularity, used by a lot of people. I found it very difficult to get my head around the programming, but I'm sure that'll come in time. What we'll do is we'll put it into action and see what it can actually do. I'm only going to cover a very small portion of this today, in particular the MQTT, which really interests me. The testing isn't going to be laboratory testing. It's going to be just a few little things that I'm going to throw together just to see how it performs. Okay, here we are in screen capture mode. First thing I'm going to do is drag an MQTT node to the workspace, and I'm going to subscribe to a feed called test, which is a feed relating to the power usage in the home, coming straight out of emoncms via a feed. Just to show you what information is actually coming into the node, if I attach a debug node and then deploy it, we should see in this window here on the right hand side data starting to flow from emoncms via MQTT into this application. And there it is. I'm currently using 551 watts, down to 75 watts, and so on. But I'll continue with this, building this up anyway. So the first thing that we need to do is to add a switch node where we can set a criteria depending upon the power being consumed. So the first thing I'm going to do is set it that if the power is equal to or above kilowatt, then it'll send an output to number 1, which I'll explain later, or if it's less than 1000 watts, it will go to output 2. And then we can see output 1 and output 2. Now we need to tell the relay board exactly what we want it to do. So we need to create a message to send. So I'm going to put a couple of change nodes so we can create a message. Join that up to there, that up to there. The relay board works really simply. If you send it a 1, it'll switch the relay on. If you send it a 0, it'll switch it off. And then we need an MQTT output node. Drag that to there. Join it all up. And then tell it where to publish to. Set the quality service to 1. And OK. And then I'll deploy that. So this now should be running. You can see it's connected to the Raspberry Pi, to the MQTT server, and as the power consumed is 418,369 watts, it's sending a 0, which is telling the relay to switch off. We'll go back to the video camera now, and we'll have a look and see how that works out. Okay, well, here we are back on the camera again. I hope you can see it on the screen. We're currently using 414, 415 watts. If I look down at the relay board, in front of each of those three relays is a little LED which signifies if the relay is activated or not. And at the moment we can see none of them are activated. So what I'm going to do is from that 400 watts I'm going to increase the load to a tad more, which is 1270 watts, and we can see the relay's lit. The LED is lit, signifying the relay is activated. If I remove the power, off it goes, and we're back down to just over 400 watts again. I'll try that again. 400 watts, 567, step it up to over a kilowatt. There we go, 1374. Relay 1's activated yet again. So that seems to work fine. But I wonder what it'd be like, what the overall system, how the overall system would react to much more traffic. Say for example, if I were to disconnect this one and perhaps load up a completely different sketch. Whoops. Which is one that I wrote earlier. And basically what this is going to do is increase the relay switching rate quite significantly. It's going to switch each relay on for half a second and then switch it back off again. It's a bit of an unfair test, I suppose, and like all things, might not work properly, but here we go. Just to make life a bit more difficult, my Raspberry Pi also has a media server installed on it, and what I'm going to do is I'm going to stream a HD quality video to my TV via Wi-Fi, and you can see it's running there now, and that's going to really push the Raspberry Pi, but it'll also just see how this little board reacts when I set this going. Just switch that off, and then if I deploy that now, you can see the data, the feeds coming through thick and fast, and it's switching each relay on for half a second and then moving on to the next one. And I think it's doing pretty well, all told. Everything's over Wi-Fi, there's no wired connections. We're streaming a full HD video direct to the TV, direct to the smart TV. And at the same time it's passing all that MQTT information to that little board, again over Wi-Fi, and I can't see a problem with that. That seems to work fine. I'm really surprised. A nice little unit. I'm well pleased with it.